Okay, so the idea is to talk about the Euclidean algorithm in cryptography, but it's not must be in cryptography. It is used in cryptography to find the greatest common divisor of two integers, a and b. So again, the idea is to find the greatest common divisor of two numbers, and the Euclidean algorithm is an algorithm in order to find it. So we have two integers, a and b. Usually we're talking about a state where a is greater or equal b, and the algorithm has steps, and we repeat these steps until we are finished. So what are the steps? We start with dividing a by b, creating our q, and the residual r. So by doing this, I'm getting that a is equal to b times q plus r, and r is the remainder. Now, if the remainder I get is 0, so I'm finished. The greater common divisor is the b that right over here. If r is not 0, it means that we are still not finished, so we are doing a replacement. We replace a by b, this value we're taking to here, and r by b, this value we're taking to here. And we are doing it again. We take a divided by b, getting q, and getting the remainder. If the remainder is 0, we are finished. The answer is right over here in b. If the remainder is not 0, again, we are doing it again. Take b, put it right inside a, and replace it. Take r, put it in b, and again, take a divided by b, get q, and get the remainder. If the remainder is 0, this is the answer. If not, take b, put it in a, take r, put it in b, and do it again. Divide a by b, get q, get r, and ask yourself this again until you do it again and again and again, until the a divided by b, every time you change b to a and r to b, until a divided by b gives you 0 in r, and then what you get in b is the answer to the greatest common divisor of the two numbers a and b. So in order to understand it better, let's see an example. So the example is that I want to get the greatest common divisor, the divisor that divide this value and that value both with a remainder of 0, but the greatest, namely the biggest number that I can get that divide both. For example, in this example, this one and that one without a remainder. This is the greatest common divisor of two numbers. So to find the greatest common divisor in two numbers, we will apply the Euclidean algorithm that we just saw to those two numbers. This is my a, this is my b. So we start as we said. I'm taking the a, this is right over here. I'm taking the b right over here. This value is 252 divided by 105, and the remainder to this deviation is in the residual value. So the q is 2 and the r is 42 in this case. Now I check if r is 0 or not. If it's 0, I've finished. The answer is in b. If it's not 0, I need to repeat by replacing a with b and b with r, and repeat this calculation. So of course r is not 0, so I need to replace. So I take b, put it where a should be, take r, put it where b should be, and doing the dividing 105 divided by 42, this is 2 with a remainder of 21. So q now is again 2, and the remainder now is 21. Again, checking if remainder is 0 or not. If 0, I got the answer right over here, but the remainder is not 0, so I need to do a replacement. Replace a with b and b with r. Take b, put it in r. Take b, put it in a area. Take r, put it in b area. And again, take 42 divided by 21. In this case, we are getting again q of 2 with a remainder of 0. Here I got r equals 0. Therefore, the answer to the greatest common divisor of the two original numbers, those two, is the b that I got right now, So this is the answer. This is the greatest common divisor of those two numbers, because I got the remainder is 0, so the answer is right over here. Note that I didn't change before this. Okay, so the greatest common divisor of 252 with 105 is 21, and we got it by the Euclidean algorithm. The greatest common divisor has many applications, for example, to know if two numbers are relatively prime and things like this, in finite groups, to know if a group is if two numbers are relatively prime, to know generator, and many things. Anyway, this is the Euclidean algorithm to find the greatest common divisor between two numbers, a and b, integers, a greater or equal b, divide, get q, get r. Put it right like this. Ask yourself about the value of r. If r0, got the answer here. If not, do a replacement and do it again and check again r. And that's it. Thank you very much. This was about the Euclidean algorithm to get the greatest common divisor between two integers, and that's it.